Hi everybody, I'm Greg Fishel. Welcome to bonus weather video number 2 for this week, and this is going to be a very detailed explanation of the ingredients that I showed you in the almanac page on the daily weather update earlier. And I put a lot of time into this, and it was fun, it really was, but I hope that this will at least make those things easier to understand. Some of you may already get it fine, and if you don't, I hope this helps a little bit. So let me go on ahead and put myself down here in the corner, and we will advance to the first slide. So let's take a look at planet Earth here. And on December 21st, on or about that date, the sun is directly overhead at 23.45 degrees south latitude. So it's 23.45 degrees south of the equator, okay? Then, on or about March 21st, and we're actually going through that right now, or September 21st, the sun is directly overhead at the equator, okay? And so it's getting higher and higher in the sky here, and by the time we get to June 21st, on or about, the sun is directly overhead at 23.45 degrees north latitude, okay? Now, the latitude at the Raleigh-Durham Airport, and it's close to this all throughout the triangle, is 35.88 degrees north latitude. So the sun never gets directly overhead of the triangle, okay? Gets fairly close, but not quite. So if you want to calculate how far above the horizon the sun will get at its peak elevation, then this is all you have to do. You take our latitude and subtract the latitude where the sun is directly overhead, and you get 12.43 degrees. Well, it's 12.43 degrees from being directly overhead, so it's like that, okay? But we usually don't think about the sun with respect to being directly overhead. We want to know how far it is above the horizon. Well, all you have to do to calculate that is simply subtract that 12.43 from 90, which is directly overhead, okay? And you get 77.57. So what that means is that on June 21st, the sun is 77.57 degrees above the horizon. So not directly overhead, but pretty high up in the sky. And all you have to do, no matter where the sun is at various times of the year, just take a look at the difference between the latitude that you live at and where the sun is directly overhead. And that difference will tell you how far it is away from being directly overhead, and then you take that number from 90 and you get the elevation above the horizon. Okay. Now, I've titled this slide, Sometimes the Sun is Sky High and Other Times the Sun is Sky Low. So let's take a look here. So imagine that you are, I think I got this right, you're lying down. My dad used to get all over me about the difference between lie and lay. I think you lay something down, but if you're talking about yourself, lying down. I hope that's right, but feel free to correct me. So imagine that you're lying down and the north part of the sky is behind you, okay? And you're looking, if you were to sit up and look forward, you're looking toward the south part of the sky, okay? And there is the part of the sky that is directly overhead. All right, so on or about December 21st, the sun rises, and this is 90 degrees here, and this is 270 degrees here, okay? So the sun rises 30 degrees south of due east and sets 30 degrees south of due west, and it never gets more than about 30 degrees above the horizon. So if this is the horizon, 10, 20, 30. And notice how short that path length is across the sky. And we all know that the shortest day of the year is on or about December 21st, so that makes sense. Now, we get to on or about March 21st, which is where we're at right now, and also September 21st, and the sun rises due east and sets due west and gets higher in the sky. So we got 10, 20, 30, 40, 50, about 55 degrees. And that should be pretty close to the elevation angle I had on that almanac page. So again, it rises due east and sets due west. Then, on or about June 21st, the sun rises 30 degrees north of due east and sets 30 degrees north of due west. And I think I mentioned this the other day that I was always told that if you had an outdoor thermometer, that you wanted to put it on the north side of the house because it would always be shaded. From March 21st to September 21st, the sun is rising in the north part of the sky and setting in the north part of the sky. So your thermometer is going to go cuckoo both early and late in the day. It'll be fine during the majority of the day, but early and late it's going to get hammered with direct sunlight unless you have the thermometer in a shelter. And again, notice how much longer this path length is here when we have the longest day of the year as opposed to the shortest day of the year. And here it's about I think about a 5-hour difference. Okay, definitions matter, okay? That's my poor excuse for a horizon, okay? Now, sunrise and sunset, as it is defined by most folks, is when the sun is no longer visible at all. If you were to define it as the middle part of the sun, okay, the midpoint as being at the horizon, then it would set earlier and it would rise, rise later, okay? So there's the sun. This is supposed to be sunrise and sunset. So sunrise is actually defined as the time the leading edge of the sun first reaches the horizon, okay? When you can see that first sliver coming up over the horizon. And sunset is defined as the time the trailing edge of the sun reaches the horizon, okay? So just by having that definition and not looking at the midpoint of the sun, we get an additional 2 to 3 minutes of daylight because the sun is not a point, it is a disk. And it actually takes some time to get completely above or below the horizon, okay? All right, moving on. The atmosphere gives us bonus light. In reality, just after, right around sunset and right around sunrise, the sun is technically below the horizon and we shouldn't be able to see it. And if we didn't have an atmosphere, we wouldn't. But the atmosphere acts like a prism and bends the sun's light toward our eyes, and so we see the sun early and late in the day when it's not technically there, okay? So the Earth's atmosphere acts like a prism and bends the light from the sun toward us, and so we see the sun even though physically it is below the horizon, okay? So, and that effect adds nearly 6 minutes of daylight, okay, about 3 minutes on each side. So the atmosphere is our friend if you like lots of daylight. Okay, the next one is going to be scary and it's the last one, but hang on. This is called the equation of time, okay? Now, it turns out that the Earth's axis is tilted at 23.45 degrees. We already talked about that. But, and this surprises a lot of people, the sun, or the Earth, is closest to the sun in January and farthest away in July. And I know that's like saying, oh, well, that means if you put your hand closer and closer to a hot stove, it'll be cooler. No, that doesn't work, okay? But in this sense, what makes our days colder is the fact that they're shorter, and also the sun is coming in at a very shallow angle, not direct at all. That's what makes it cold in the wintertime, not the distance from the sun, but the angle at which the solar radiation is hitting us, okay? And so when the Earth is closer to the sun in January, it moves faster, okay? Because the force of gravity is, pulling it along faster. And then in July, when it's farther away, the Earth is moving slower. So the Earth-Sun time system is not always going to work out with our time system, because in our time system, everything is equal. All the days are the same length and so forth. And the Earth, or the sun time system, is not like that, okay? So this blue line here represents the equation of time through the year. And basically what it is a correction factor that allows us to calculate when the sun will rise and when the sun will set. And you can see that it gets as low as almost 15 minutes minus here, and as high as about 16 minutes on the plus side up here. Now the orange line is solar noon, okay? And that's when the sun is highest in the sky and directly south. Like if you're, again, lying down and you sit up and you're facing due south, okay, that's where the sun's going to be, okay, is directly ahead of you. And so, and the axis or the readings for this graph are over here, okay? So this graph goes from 11:55:41 a.m. to 12:31:41 p.m., okay? And notice how these two are inversely proportional. When the equation of time is low, then the solar noon occurs later, okay? And this one goes, this goes up, this goes down, this goes down, this goes up, and then again, the opposite here. This is the solar noon down and the equation of time up. So they're inversely proportional, okay? And the interesting thing, let's just give you a couple of values here. On February 13th, the equation of time is minus 14.599 minutes. Solar noon is at 12:29 p.m., okay? So that's when the sun is directly south. Now, on July 26th, the equation of time is minus 6.18, but solar noon is now a little bit earlier at 12:21, and technically it's 1:21 because we're on daylight saving time. If I would have accounted for daylight saving time, then there would have been a big jump in the graph right when daylight saving time started and when it ends, and I wanted everything to be nice and smooth, so that's why it looks like this. And then finally, on October 30th, the equation of time peaks at plus 16.45 minutes, and solar noon by that time is 11:58. But we're still, I think that's right, in daylight saving time October 30th, so that would actually be 12:58 p.m., okay? So you have to correct for that. So that is purely a function of the fact that the Earth's axis is tilted, and also the Earth is moving at different speeds at different times of the year around the sun because of its varying distance from the sun. All right. That is it. There are the credits. I hope you found that, if nothing else, interesting and hopefully helpful. That is the bonus weather video for today. And the next one will be Friday. And the next daily weather update, of course, coming up tomorrow. So you all have a wonderful, wonderful Wednesday evening. And, just to be fair, and I think I mentioned this the other day as well, we had all this talk about the sun today. And I really think that at some point we have to do an equal amount of time for the daughter. It would only be fair. All right, folks, you all take care, and we'll see you tomorrow. See you later.